Hello, this is Nigel Ward, CS3360. These are our COVID-19 tribute lecture series, slapdash fragmentary lectures that will just get you enough information to do the assignments and guide you through the book and the readings. So, you've all read a big chunk of chapter 16, or if you haven't, you will do that right after listening to the lectures. This one will just take about 5 minutes, I think. Any questions right now on chapter 16?
No?
All right, you just heard the voice of our virtual classmate. I'll call her Isabel. She'll be standing in for you guys in case you have any questions. Of course, real questions you can post to the forum or you can visit me during office hours. All right, so why do people disagree? Why can't we just write down the basic true facts and the rules of correct reasoning and then do some computations and figure out the truth? Way back when Aristotle invented syllogisms, the book talks about these, right? So if we know that Socrates is a man, and we know that all men are mortal, then we can infer that Socrates is mortal. So we've written down two basic truths. One of them is actually a rule, and we can find new truths from that. So in the 1920s, people in the Vienna Circle, these were mathematicians and philosophers, got really serious about coming up with a research program to actually build systems that would do this for you. Unfortunately, this nasty guy, Kurt Gödel, came along in 1931 and he proved a bunch of theorems to show that some problems are undecidable. When you take automata theory, CS3350, you will learn about the techniques he used. If you go on to graduate school, you'll learn more about that. It's very deep, very interesting, and amazingly importantly practical. Okay, so, those people died off. It's like, oh, well, we can't prove everything. It's impossible to just write this logic machine and find the truth for everything. So we'll go and worry about different techniques for studying logical, philosophical problems. But this idea was sort of revived in the 70s, and this was a bunch of people from France who thought about the concept of programmation en logique. I think I said that right. And you can guess that from programmation en logique, the name Prolog arose. So the idea is to use logic sometimes to solve some problems. So the key notions of Prolog. So you state the facts. Man, Jake, like Bob Steak, you state the facts, and that's knowledge. So you're putting knowledge into the system. Now it's declarative. So most programming languages are imperative. You tell the system what you want it to do. Do this, add that, jump here, for x equals blah, blah, blah. Prolog's not that way. It's completely declarative. You declare, these are the facts, this is what I know, and hey, I trust you. Prove some stuff. So the system uses the knowledge to find proofs. Now the proofs are mostly requested by queries. As I say, it doesn't try and prove everything in the world from the knowledge you gave it, but you'll give it a query, and it'll try to find a proof of your query, find a proof that your query is true given the knowledge that it has. So there's the basic concepts. Any questions to this point?
No.
Okay. All right. So proofs are done in different ways. There's resolution, unification, and other methods. Those are not so important for us. The book explains how backtracking works. That's the most basic method. It's interesting. It'll help you understand why your program is working or not working, but not so essential. All right. So nobody ever, for the past 30 years, has gotten a job programming in Prolog. So I'm teaching it to you not because it's like C++ where you can get jobs, but because it's really a new programming paradigm, a new way of thinking about problems. Prolog and Prolog-like concepts, especially the concept of declarative knowledge, is used here and there, and it pops up all over the place. There are many sister systems to Prolog for theorem proving and solving constraints. If you're interested in that, that's actually Dr. Sabir's research area, so we'll go give her a chat. Okay, so here's some notation for you. I think you saw this in the book. Any questions on the notation?
No.
No, okay. Most of you have already seen this in discrete mathematics or discrete structures. And so if I say Mary is human, is implied by Mary is female. So that little is implied by thing can be written in different ways. So this is sort of like a mathematical way to do it. So you can think of it as the worlds in which Mary is human are a superset of those in which Mary is female. Okay, that's sort of the mathematical way to look at it. If you're right in terms of set theory. If you're just doing it in terms of normal implications, you'll use the double arrow. Mary is female implies Mary is human. Now, in discrete structures, you probably wrote it the other way, right? So Mary is female implies Mary is human. But Prolog likes to do things backwards. It's just the syntax, doesn't have any great significance. Now, on your keyboard, there's no backwards double arrow key. And so in Prolog, we use this thing. And every time you type that, it kind of, if you imagine it correctly, looks like a backwards double arrow. So, but it means the same thing. All right, so these are some implications. All right, now, if you're going to write down all the facts in the world about every specific item, Mary, for example, it's going to take you a long time. So we have variables. So variables in Prolog are written as capital letters, and we can say things like human of X is implied by female of X. Okay, so this is a rule or a structure, and it tells us one way to show that somebody is human. Okay. Now these things are variables. Now you guys are used to mostly variables in imperative languages, and then place you have control. So you can say X equals 3, right? So you have control of a little location in the memory of your computer, and you tell the language what you want to do, what you want to put there. Prolog, you don't have that control. Prolog variables are very different. You cannot assign to Prolog variables. It's up to Prolog. Prolog will try and find a way to make it true. It'll use them as representations of propositions, but you can't assign to variables. As you work through the exercises, that will become very, very clear to you. All right, so far so good?
Yes.
All right, good. Okay, so now you can write any propositions you like. Their truth is entirely up to you, right? And so, I'm not sure these propositions are actually true. So you know what? There might be female cattle, or there might be female monkeys, or there might be female, and not all of those things are insects. Not all of the things are human, right? So this is actually completely bogus and false, unless for some reason we know that the only items in our world are human to begin with. Okay, well, that's my problem. I did this wrong. Prolog doesn't care. Prolog is picky about the syntax, right? You got to do things in the correct format, but the semantics, that's up to you. So if you write nonsense propositions or nonsense knowledge, Prolog will happily do completely accurate proofs of nonsense things. All right. Well, that was a short lecture. What's next for you is you've got to review list structures and the rules for matching. Now, we talked about list structures before. We have those in Lisp, and you'll see them again in Haskell. Prolog is a different notation, so you need to get used to that. Go through learnprolognow.org, chapters 2 through 4, and there's other tutorials out there, of course. If you find other tutorials, you can write them down in the comments on this YouTube video so that your classmates can find them, or you can post them on the discussion forum and write some predicates. I've got an actual assignment, Prolog assignment part 2 will give you some specific predicates that you need to write. All right, that's it for today. Goodbye.